program, outreach program in astronomical discovery targeted for high schools and college students. Occasionally, we also have middle students participate. The collaboration, or we call it IASC, was founded in October 2006 at the university, and students who participate from the various schools make original discoveries of solar system objects, including main belt asteroids and near-Earth objects, Trojan asteroids, centaurs, trans-Neptunian objects, Neptunian objects, TNOs, and even comets. Here's how it works. We have a number of observatories around the world that collaborate with us. One is Pan-STARRS. We use the 1.8 meter Pan-STARRS telescope managed by the University of Hawaii on Haleakala in Maui. And they send us a series of fields taken over an evening. We get 4 images per field, taken the same field over a 1 hour time period. We partition those and distribute those out to schools on our online site at Hardin-Simmons. The students come in that next morning, where they download the images that they've been assigned, each school getting its own unique set of images, and they use the program Astrometrica to search for, discover, and measure any asteroid discoveries. If they make a discovery, the Minor Planet Center requires that within about 7 to 10 days, you have to go and observe it and make a second observation. And we have another network of telescopes around the world that assist us in doing this, one of which is Las Cumbres Observatory, where we make use of their 2-meter Fox telescope in Haleakala and sometimes Siding Springs. And we repeat the process. A few days later, we send them the coordinates. We put the coordinates in the queue, and we re-image the asteroid discovery made by the students, and we repeat the process. We measure we take the second measurement, then we bundle the measurements that were made originally by the students, and then secondly, during the second detection, we bundle those together and send those to the Minor Planet Center at Harvard. Now here are just some basic statistics about the program. The top table there shows you the growth from the time we started during academic year 2006 and 2007. That first year we had 20 schools, about 140 students thereabouts, from 3 different countries. By 2014, the academic year 14, we had grown to 300 schools in 50 countries, and then have grown every year since then to 500 schools in 2015, 700 schools in the current academic year, and the next academic year we're going to 1,000 schools located in 80 countries, and that will reach about 7,000 students worldwide. The bottom chart you see there shows you the ethnicity or ethnic breakdown of the participating students. The only caveat is that the data there about Indian is not Native American Indian. It's actually the country of India. So my staff put that together and gave it to me. Let me talk a little bit about the telescopes that participate. This is the 1.8 meter Pan-STARRS 1 telescope in Haleakala. Pan-STARRS, of course, is a panoramic survey telescope and rapid response system. It's managed by the Institute for Astronomy at the University of Hawaii. It's not the world's largest telescope, however. It does have the world's largest digital scientific camera, which produces images that cover 7 square degree fields. In fact, one image contains about 1.4 billion pixels. During a 30-day search campaign, and I'll talk a little bit more about what a campaign is here in a moment, we'll get 12 images from that telescope during that 30-day time period. And then we'll partition each of those into 208 subfields and distribute those out to 100 schools. And from one image, the students will discover more than 150 main belt asteroids. Of these, there'll be 20 that are faint asteroids that are not detected by the Pan-STARRS automated pipeline. And we know in about every 6th image that we get from Pan-STARRS, there's an NEO, a near-Earth object, that's not detected either by the pipeline. We are just starting a new collaboration with the Catalina Sky Survey, which is managed by the Lunar and Planetary Laboratory at the University of Arizona. The photograph there on the bottom left is the 1.5 meter G96 telescope on Mount Lemmon. Attached to that telescope is a 10 gauge by 10 gauge camera that produces 5 square degree fields. And then we'll take those fields, partition them into 4 subfields, and then distribute the 4 subfields out to participating schools. We know that based upon a pilot campaign that we just completed over the previous 30 days, that in about every 4th image that we get from Catalina, we'll find a main belt asteroid that was not detected by the Catalina automated pipeline. Not sure yet what the NEO discovery rate is. We need some more data to make that determination. But we know that there are some faint NEOs that are being missed by that pipeline that will certainly be detected by the participating students. In the past, we worked with this facility. This is the Astronomical Research Institute in West Illinois. Bob Holmes' operation. We used the 0.81 meter, 1.27 meter prime focus telescope there. And they participated in IASC from 2007 into 2015. And during that time, students made discoveries of MBAs and NEOs and even 1 TNO. They also made thousands of NEO confirmation observations. Confirmation observation would be after the original detection of an NEO would be the 2nd or 3rd observation of that near-Earth object. We've also used these telescopes for campaigns. Las Cumbres Observatory, we've used the 2-meter Fox telescope in Haleakala to run campaigns. And more recently, we've used the 3 1-meter telescopes located in Sutherland in South Africa, part of the 1-meter network of Las Cumbres, also to run campaigns, taking images from the Southern Hemisphere. We've also participated or worked with the Sierra Stars Observatory Network using the 0.81 meter Schulman at the Mount Lemmon Sky Center. As a matter of fact, was that particular telescope which we discovered a comet. Now, each year we have 7 student search campaigns with 100 schools in each campaign. Next year, that's going to go to 145 schools in each campaign as we expand the program to 1,000 schools. The campaigns are timed based upon lunation. A campaign starts with the 3rd quarter moon and continues for 30 days. It's during 3rd quarter to 1st quarter, that 2-week time period, that the surveys collect, or that Catalina and Pan-STARRS collect their survey images that for along the ecliptic that we distribute out to the schools for the students to make their discoveries. And since starting in October 2006, students have made this list of discoveries: over 1,250 provisional MBAs, 43 numbered main belt asteroids, 5 provisional TNOs, 2 numbered TNOs, 10 NEO provisionals, including 2009 BD81, which is a potentially hazardous asteroid, and the 1 Jupiter family comet. In terms of growth, here's what we're looking over the next 5 years. We're going to expand IASC to a cloud-based environment, basically giving it unlimited storage capability and distribution capability. When we do that, we'll grow the program to 2,500 schools, which should reach about 18,000 students. And our target will be 500 of those schools will be in the U.S. We're also going to open up a discovery portal to the general public, and have, we hope to attract 10,000 citizen scientists to participate in that portal worldwide and make discoveries of NEOs. And finally, we want to develop a TNO search campaign. We plan to do that with Pan-STARRS, because we know we can discover TNOs in Pan-STARRS data. Also, the Dark Energy Survey at the University of Michigan, and the PSIGA, that's close enough, Astronomical Research Institute, Perry, in North Carolina, working with them to develop these TNO search campaigns over the next, over that 5-year time period. Now, here are some of the students who made discoveries. This is a high school student in Hyannisport, Massachusetts, who made a discovery, a provisional discovery, a number of years ago. She's now graduated and high school and gone off to university. These are community college students at the Spring Creek campus in Collin County near Dallas, who made 3 provisional discoveries. This is Gustavo Rojas and his students near Puerto Alegre in Brazil. They've been actively participating in IASC for many years. As a matter of fact, we have about 50 schools that participate throughout that country. Bulgaria, we have about 20 schools that participate in Bulgaria, and here you see a group of students who are participating in one of the IASC campaigns. And China. This is Hongfeng Gao with the China Hands-On Universe. At the time, she was with the National Astronomical Observatories of China, Chinese Academy of Sciences. And she's there posing for this photograph with students from Beijing High School. And we have about 20 schools and groups from Beijing, the Beijing area that participate in IASC. This is Portugal. We have 75 schools that participate in Portugal, many of which are middle schools. Probably about half of those are middle school students. Japan, these are students from Shizuoka University in Japan. There's a second photograph showing the students who are actively using Astrometrica to search for and discover and measure asteroids from data that we sent them. This is a high school outside of Manassas, Broadmoor High School in Virginia. Another high school in Virginia. This is Thomas Jefferson Technical High School in Alexandria. Mozambique, these are 3 university students in Mozambique who are using Astrometrica to search for asteroids using images that we provided. India, we have, this summer we have 150 schools that are participating from India through an organization, Space, located in New Delhi. And next summer, that's going to grow to 200 schools. And Poland. Poland was one of the 3 original countries that participated in IASC in 2007, and they've been participating every year since. We have about 30 schools, 30 to 40 schools that participate in Poland. And here's a photograph during an award ceremony where one of the students was receiving an award for having made some discoveries.
You've got 3 minutes left, Patrick.
All right. These are students from Brazil showing their certificates. Sao Tome y Principe, students getting ready to search for, on the screen there, for asteroids. And this is a school in Morocco, in an isolated area of Morocco, where they're having a celebration where they're showing their certificates for their participation in discoveries that they made in one of the 30-day campaigns. And over there on the left is our list of collaborators, from Pan-STARRS, the Sierra Stars, to Catalina, Las Cumbres, Caprelli in northern Italy, all the way down to that list of the Dark Energy Survey, University of Michigan. And on the comment there, you see the different organizations, astronomical education organizations primarily, there's some astronomy clubs too, that reach out to their communities and train teachers and groups to participate in IASC. And in closing, I did forget to mention one thing. IASC is free. There is no cost to the participating schools, teachers, or students, and there's no cost to the astronomy outreach organizations and clubs that we serve. The images and the use of all professional astronomical facilities are donated by the collaborators. So that's what we do in IASC.
All right, we have time for a question or two.
Hi, Patrick. This is Edward Gomez.
Edward, how are you doing?
Hi, very good, thank you. A shame to not have you here in person. Could you say a little more about the cloud-based web tools that is in the 5-year plan?
Well, I'm not sure I can, because we just made our original proposal to NASA to support that project. So that's really in the hands of the programmers. So I'm not sure what they plan. But the idea is that we make use of the cloud for storage and then distribution. I do know one of the things, when we set up the Discovery portal, we'll set that up so that the FITS images are transformed into JPEGs, and then the general public will blink through the images using a JPEG blinker, and then they'll mark the discovery, report that back to us, and then we'll rate them. We have a system whereby we rate those, and then we'll go in and manually ourselves take a look at those candidates and decide if they're false detections or real detections.
There's a question over there.
Hi, Patrick. It's Jeff. You didn't mention this, but I think it's highly illustrative of such a successful project. Could you tell us how many people it takes to support ISAC?
There are about just the base level. There are about 10 volunteers. We only have one paid staff member, and that's my technical assistant here at the university. The rest are, as Jeff points out, volunteers. There are probably 20 to 30 volunteers worldwide in ISAC to participate, most of whom I've never met. I just interact with them over the internet, and they come to me and say, well, this is interesting, I'd like something to do. And so we figure out how to train them and give them access to some of these world-class facilities. And they work tirelessly to support this program. Without them, we would not be successful.
Okay. Oh, one more question and then we'll move on. Russ.
How did you get started in ISAC? What brought ISAC on it? What was the original?
Well, you can blame Carl Pennypacker for that. He's sitting there among you, I think. He usually falls asleep during my presentation, or he gets up and goes have a cup of coffee. I don't blame him. I do the same thing to him. He was my doctoral advisor. I got a doctorate in astronomy very late in life, and he was my advisor, and he was showing me about Hands-On Universe. And in the 1990s, Hands-On Universe tried to do a search program like this, and we're somewhat successful. I think they discovered an asteroid or two, and even a TNO, one of the first TNOs ever discovered. But the internet was not yet ready for it, and the CCD technology was just coming online. Large telescopes in the hands of private consumers or private individuals, that hadn't developed yet. But after that developed, that's what led to ISAC being successful. But one day I was sitting around in my office with an undergraduate, figuring out, well, let's do something in astronomy. What do you want to do? I said, well, the Hands-On Universe thing, they used to have an asteroid discovery program, and we thought that might be kind of neat to do. Keep in mind, I had no idea how to discover asteroids, but it didn't stop us, and it subsequently changed what I do professionally, and it's been amazing experience, just going from a simple idea to what the program has developed today because of the volunteers and the support of these professional facilities.
All right. Well, thank you very much, Patrick.
All right. Thank you.
All right. So we're going to, in about